Alright, today we're finishing the topic from Friday, chapter 6, topic 6, rational exponents, day 2. Whoops. Alright, we're going to look at how do we simplify with rational exponents. So first, a to the 2/7 times a to the 4/7. So this, you use the same properties as you did with exponents, okay? When you multiply, you add the exponents. So this is a to the 2/7 plus 4/7. Alright, so this is a to the 6/7 power. Make sure I'm supposed to be writing these as, yeah, okay. Writing these in the correct form. Alright, a to the 6/7 power, because I just add the exponents together. Number 2, b to the negative 5/6 power. So I just need to, what does this one want? Oh yeah, okay, that's what I thought. I just need to write this in the proper form. It's not supposed to have a negative exponent, so I'll put it in the denominator so that it will have a positive exponent. So b to the 1/b to the 5/6 power. Number 3, same thing, I have to add these. So the exponents get added, 1/4 plus 9/2. Alright, but remember, you can only add them if they have common denominator. So I will have to change the denominator so that they both have a denominator of 4. So this would be 1/4 plus 18/4. Just multiply them both by 2. 9 times 2 and 2 times 2. Sorry, 18/4. So that's going to give me 19/4 as my exponent. So p to the 19/4. Now, number 4, it looks like I'm adding. Now, keep in mind, this is the 5th root of a plus the 5th root of a. You can only add these if they're the same variable. It'd be like x plus x would be 2x. Okay, but this is a to the 1/5 plus a to the 1/5. So this would be 2a to the 1/5. Alright, because these are just variables. They have to be the same. They have to have the same exponents, just like x squareds can be added together. X squared plus x squared would be 2x squared. X cubed plus x cubed would be 2x cubed. A 1/5 plus a to the 1/5 is 2a to the 1/5. Alright, now this one is division. So remember, when you're dividing, you subtract the exponents. So our new exponent would be 3/8 minus 1/4. But we do need common denominators. So the 8 is fine. I need to change the second one so that it has a denominator of 8, which means multiplying by 2. So 2/8. 1 times 2 is 2, 4 times 2 is 8. And now I can subtract them. 3 minus 2 is 1, so this is 1/8. M to the 1/8 power. Alright, now this one has a lot of stuff to do here, because not only do I need to combine the ones on the bottom, I need to subtract them, divide from the top one. Okay, so let me first start by combining these two, g to the 1/2 and g to the 3/8. So I need to combine those by adding the exponents, 1/2 plus 3/8, which means common denominator of 4. So this is 4/8 plus 3/8, which is 7/8. Okay, so what I'm actually looking at here is g 7/4 divided by 3g 7/8. Okay, well now I can combine these by using subtraction. Okay, so I'm going to have, I still have the 3 in the denominator. That's unfortunate, it's going to stay there. But the denominator, I'll have 7/4 minus 7/8. Okay, I do need to use a common denominator here. So a common denominator would be 8. So it's 14/8 minus 7/8. and the 3 still in the denominator. Yeah, because multiplied by 2. 14 minus 7 is 7, so this is g 7/8 power over 3. Alright, that one was a little bit messy. There's a lot of stuff to do here. I needed to combine these by using the product property. I need to combine these by using the subtraction property, etc. Alright, now we are going to be starting on the next topic, which is topic 7. This is the introduction to topic 7, which will start tomorrow, which is solving radical equations. So actually solving these types of equations. So the steps are as follows. You isolate the radical. You raise both sides to the n power to get rid of the radical. The n power is whatever the index is. And then you solve, and you check for any extraneous solutions that do not make the original equation true. So if you find numbers, you need to check for each of them to see if they actually work in the equation. So let's start with this first one, solving. Is it on the next page? No. Okay. Solving square root of x plus 2 minus 4 equals 7. Okay, so first we get that radical by itself. So minus 4. So we got square root of x plus 2 is equal to 3. The index here is 2. So to get rid of the index 2, we would square both sides. And that will get rid of our radical for us. We'll have x plus 2 is equal to 9. Alright, we'll subtract 2. And we get x is equal to 7. And let's check this solution. 7 plus 2 is 9. The square root of 9 is 3, and 3 plus 4 equals 7. So here we have our solution, x equals 7. Yep, x equals 7. Whoops, not what I wanted. Alright, so our solution to number 1, x is equal to 7. Let's take a look at number 5. First of all, we will isolate the radical, which is right here. We'll do that by adding 1. We get 6 is equal to the cubed root of x minus 2. Alright, now we need to get rid of that index. We need to get rid of the radical. So we're going to do that by cubing both sides. Alright, so 6 cubed is 216. 216 is equal to x minus 2. We'll add 2 to both sides. We get x is equal to 218. Let's check this solution in the problem. 218 minus 2 is equal to 216. The cubed root of 216 is 6, and 6 minus 1 is 5. So the 218 will work in the problem. Alright, let's take a look at number 3. So first of all, isolate the radical term. So we have a negative 3 on the outside, which means we're going to have to divide by negative 3 to get rid of that. We got the fourth root of x minus 1 is equal to negative 12 divided by negative 3, which is 4. Alright, next we need to get rid of that index. So we'll raise to the 4th power. So x minus 1 is equal to 4 to the 4th power, 256. And then we'll add 1, x equals 257. Whoops, I got dyslexia here. Alright. Alright, let's check this in the original problem. Alright, 257 minus 1 is 256. The fourth root of 256 is 4, and negative 3 times 4 is negative 12. So this works in the original problem, x equals 257. Alright, the homework for this one, 87, 17 through 23, 88, 18 through 20.